In this video, we discuss problem 9.2.VE.002 from Larson and Edwards Calculus Early Transcendental Functions, 7th edition. This is just a true-false question, and it's a little bit tricky, so I wanted to go over this with you. It says true or false, the series of with terms a sub n converges if the limit as n goes to infinity of a sub n equals 0. Now, one of my students sent this to me and said, doesn't theorem 9.8 contradict this? The answer turns out to be false, and the student was sure that the answer was true because theorem 9.8 says that if this series converges, then this limit is equal to 0. Now, you should also know that 9.9 says that if that limit is not equal to 0, then the corresponding series diverges. And that's actually what the person in our video, the video that is associated with this question, was talking about. When he said, let's say that a sub n is 5, and you just have infinitely many 5s, then the limit as n goes to infinity of a sub n would just be 5, because you've got 5 and 5 and 5 and 5 forever. So it doesn't matter what n is, a sub n is 5, so the limit is 5. But then things change. When I try to add infinitely many 5s together, I'm going to get infinity. Like, that's the only thing that could possibly happen there. So you can't add infinitely many 5s together, because then it would diverge. Now, theorem 9.8 says that if a series converges, then the limit of the nth term as n goes to infinity has to be 0. So what this is saying is that those numbers that we're adding up over here, they have to be getting smaller and smaller and smaller so that you can add them together and get a finite number here. Now, this is not saying the same thing as this. This looks very similar to this, but this is not saying the same thing as this. This is saying the series a sub n converges if the limit as n goes to infinity of a sub n equals 0. Or in other words, they're saying that if the limit as n goes to infinity of a sub n equals 0, this converges. And that's actually not guaranteed. That's not this statement, but that's a related statement. That's like taking this statement and then writing it backwards. Instead of saying, if this is true, then this is true, they're saying, if this is true, then this is true. And it actually doesn't work that way. Here's an example. If a sub n is equal to 1 over n, we have what's called the harmonic series. Now, if I look at the terms of the sequence a sub n, when n equals 1, I just get 1. When n equals 2, I get 1/2. When n equals 3, I get 1/3, and so on. The nth term is 1 over n, and we just keep going. Clearly, as n goes to infinity, this goes to 0. Or if you just want to look at the limit, as n gets really large, 1 over a really large number is something really small. So this is the same as saying that the limit as n goes to infinity of a sub n is equal to 0. Now, if this was true, the fact that this was equal to 0 would imply that the series for 1 over n. So we're going to add from n equals 1 to infinity 1 over n. So we'll have 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5 and so on, all the way through down here. And actually this diverges. We can prove this diverges using the integral test. And we actually do that in the videos for our course. We show that a P series with P equals 1, this series must diverge by the integral test. But I wanted to show you this example as a counterexample to this idea, because what this is saying is this, and I know it seems like it's identical to this, but it's really not. There's no if in front of this part. It says, this series converges if this is true. Or in other words, this statement is if the limit as n goes to infinity of a sub n is 0, then the series converges. And that's not true. If the series converges, we're guaranteed that the limit of the nth term must be 0, because those numbers that we're adding together, they have to get small for us to be able to add all of them up and get a finite number. But just because those numbers are getting small doesn't mean that you can add them up and get a finite number. So it's a finer point. This is your counterexample. And again, we're going to prove this later when we talk about the integral test. So that's why this is false, because this statement is not equivalent to theorem 9.8. This statement is equivalent to this statement. It's kind of like 9.8, but flipped. And since it's flipped, it's not the same thing, and it needs to be considered separately. And it turns out that when we consider it separately, it just doesn't hold up. This is an example where we have, this is what we call the counterexample. This is an example where we have a limit that is equal to 0 and the corresponding series that diverges. So this limit equaling 0 can't imply that this corresponding series will converge, because sometimes you have a limit of 0 and it diverges. So let's see, what is the major takeaway? Let's look at these two theorems and then think about this example again. It says, if the series converges, then we are certain, we can be absolutely certain that the nth term goes to 0. Because if I'm adding up numbers that are getting, because if this sum converges, if I am adding up infinitely many numbers and I get a finite result, those numbers must be getting smaller and smaller. That's the only way that can happen. Now, this is saying, this is what's called the contrapositive of that. This is saying, this says, if this is true, then this is true. This is saying, if this is not true, then this is not true. And these are equivalent to each other. This implies this, actually. What this says is that if the limit is not 0, so if the limit happens to be 5, like he was showing you in that example, if you add up infinitely many 5s, you're going to get or infinitely many numbers that are eventually getting very, very close to 5. Eventually, it's going to be like adding 5 and 5 and 5 and 5 over and over again, like infinitely. And so you're definitely going to get something that goes to infinity, and that the sum will diverge. So this says, if the limit of the nth term is not 0, the sum diverges. This says, if the sum converges, then the limit must be 0. Now, if you're saying, but what if the limit is 0? Here it is. If the limit as n goes to infinity of a sub n is 0, then the series may converge, or it might diverge. The fact that the limit as n goes to infinity of a sub n equals 0 doesn't really tell you anything about this corresponding series. When you find out that the limit is 0, all that tells you is that the series might converge, but it might not. And here's an example where it doesn't. I hope that helps. If it doesn't help, let me know.